I know everything, correct? Not that. So here, the technology that what we are using, okay, as I said, it's built on Google Cloud Platform, and we also use Qflow, and we also use Spark ML, and we also use PySpark. Okay, so I will explain what exactly each one of this does actually. Then we have Python, which is basically a programming construct. Then we use NLTK. Okay, so then we use pandas, MATLAB Live, Wave. So this is the collection of toolkits that what we use to build this one. Okay, so if you look at Qflow, what is the purpose of using Qflow? That's for the pipeline. So model pipeline. So when I say model pipeline, when a conversation takes place, that conversation automatically recorded, and that is transformed into voice to text in a live system. Once that is transferred, then the model is going to analyze this one using deep speech. Okay? So all these things has a role to play. PySpark primarily used for Spark, and PySpark is used for distributed training. Okay? So when you want to train a model, you can train in a sequential way. Okay? You have 1 million record, you process one by one, or you can split this one in a multiple files and then multiple systems then get trained actually. So it's more for a distributed training. So the technology that what has been used to build this one, correct? It is just not only Python. In our case, Python is just 0.5% or maybe 1%, 2%, that's it. So there are several technologies used. As I told you, the entire infrastructure is built on Google Cloud, and we used Qflow for pipeline, model pipeline, and we use PySpark and Spark for distributed training. That includes data parallelism, model parallelism. So model will be trained in parallel, data will be processed in parallel. And then in terms of working with the data, we use Python, pandas, and then we use MATLAB Live for the graphical visualization, right? What you looked at. So deep speech is for converting voice to speech, analyzing voice data. And NLTK is for the natural language processing, which is basically extracting hidden insights on the data side, correct? All the things we use them actually. Okay, so in terms of what I told you about, there are two key components that what we are built: model pipeline, data pipeline, how the model gets the data and how the model is performing. So as we talked about, the model pipeline is built on Google Cloud bucket. We use Jupyter Notebook, Qflow, Kubernetes, Docker. And data pipeline, it's PySpark, Hadoop, Big Data Technology, MySQL. So this is a combination of technology to build the data pipeline, model pipeline. As I told you, some of the data that's coming from Amazon, and it is hosted on Google Cloud. Okay, so again, there are so many different things that I can go through. I am not going to spend time on this one. So in terms of how do we implement it, I have given here actually. So number one, deep learning architecture. With any configuration that is involved, just work on this one. And working with deep learning and text analytics libraries, analyzing text and libraries, okay? And the next is working with deep learning models and converting voice to text. And then once we've done this one, extracting clinical symptoms from the text file and working with the text classification, text analysis, and then performing insights. Correct? These are the six different key steps, correct? What we are performing actually. So let me quickly show you the code so that you can understand. So this is a code block. So I'm going to take you to our GitHub, correct? So this is basically where we have our codes out here. Okay, so if we could go to I'm in GitHub. Okay, so when I go here, okay, you can see here, this is basically our company GitHub accounts, correct? So once I log in, I can get to see everything what has been done here, correct? So let me start from the beginning so that you could understand. Okay, so this is our GitHub repository. So when I go here, you can see, so this is basically, there are different folders here, how we organized. So if you want to understand the problem statement, if you want to know the data, if you want to know the model architecture, everything is here, correct? So let me go to the code block. So this is basically model implementation source code. When you go inside, we have different files. Ignore these files. Go to the SRC, that's the source code. So when you go inside, you can see this is the Python program that what has been written. Actually, it's still loading. So you will understand here. Okay. So the first one is download the data. The data that what we need actually, as I told you, when we have voice, the conversation that takes place between the doctor and a patient, that is stored in Google Cloud. Okay, you see on the top, correct? This is on the Google Cloud. So download the data. Okay, it depends on how you want to do it. In our case, I'm for the demo purpose, I'm showing this one. It was a live data. That means real-time data streaming. real-time data streaming. As and when a conversation started, we stream and we record the data that recorded in the Google Cloud. All right, so that is what this section of the code does. Okay, so this section of the code is basically like, get the data from the Google Cloud bucket. Correct? Like, if you're familiar with Google Cloud, you'll understand it's coming from the bucket. So number one, once we have the data, this is basically what it is, the actual voice data. Okay, so the second is in a YAML file. What is this file does actually? So this is basically the configuration file, what is required for us to work on. Correct? Like, if you see here, we don't hard code any of those paths. Correct? Like, all we have is, this is like an INI file. This has everything what we need actually. Okay, so first step is download the voice. Okay, as soon as the doctor is talking to a patient, correct, the voice getting recorded in a Google Cloud bucket. From there, I'm going to download that into my program. Once I download, then I wanted to use in a config file which has all the library, everything that is required. So that file, I'm going to use this one. Okay, then I'm going to import all the required libraries. You can see NLTK. Okay, so we can see pandas, you can see MATLAB lib, correct? So config forcer, etc. Correct? So all these different files, whatever I need, I'm importing these files. Correct? I'm importing these files. Once I import this one, actually, then the next is deep speech. What is deep speech? That's actually, okay, one of the deep learning model. So that model is to convert audio to text. Correct? So now what I'm doing actually, I'm taking the patient voice and transforming into a text. Correct? Transforming that into a text. Keep in mind, these are all happens on a live. That is why we want a model pipeline, data pipeline. Correct? If you noticed what I told, there is two key component, correct? So which is model pipeline, data pipeline. If we don't have this, you won't be able to implement this one. I'm talking about how do we get the data, correct? How do we get the data to the model to run? That is number one. Second, the model to continue to perform, correct? The model for continue to perform, I need a model pipeline. So these two are built a combination of technologies, okay? Combination of technologies, correct? As I told you, if you noticed, I talked about Google Cloud bucket. That is where the actual data stored. Jupyter Notebook, that is basically kind of an IDE for me to run programs, write programs, and etc. Kubeflow creates a pipeline. Kubernetes creates a runtime infrastructure for Kubeflow to work. Docker packages everything, right? All these things has to be done in order to make this program work, right? So I'm just saying, in a real world, it is not simply writing a piece of Python code, right? You have to make all these technologies work, and that is what happening here. Okay, that is what happening here. All right. So now my infrastructure is ready. I'm going to convert audio to text. Whatever the conversation that is happening between a doctor and a patient, that's audio. Transform that into a text. So that is what this section does. Correct? I won't be able to go line by line code. Whoever needs, I can share the GitHub link. You can go ahead and figure out. You can build your thing. All right. So now what I'm talking about, actually, I want to extract the symptoms, what I see here. Okay. So once I have this one, my goal is to find out whatever the doctor and patient conversation that took place. In that conversation, I want to extract symptoms. Okay. I want to extract symptoms. So this is Google's API. Correct? It's an API. It's you would call a pre-trained model. Okay, you can call it as a pre-trained model. So this is basically again from a Google. Okay, so what you noticed here, actually, I'm extracting all the symptoms that has been spoken. Okay, so once I extract, actually, then I'm going to predict what kind of symptom it is. Okay, so are they talking about a headache? Are they talking about stomach pain? Are they talking about fever? What are they talking about? I'm going to extract that one. Okay, so if you could see NER, okay, so if it stands for NER stands for named entity recognition, correct? Named entity recognition. So that is what we are using. So this section of the code extracts symptoms from the voice that what we translated into text, correct? So once the text is there, using the text, okay, we are extracting all the symptoms that is been there. Then we are classifying that symptoms, whatever we find, correct? Where does it fall in there? Okay, is it kind of like, based on the severity of illness, we are going to classify this one. Once we classify this one, then we build the data visualization part, correct? And that is what you have seen here, actually, correct? So the data visualization, what I'm talking about here, you can see like in the in the PDF that I was trying to show you. So this has all the symptoms and warnings that has been extracted. Right? So this is basically overall how this works. Correct? Again, if you noticed here, since we use a lot of pre-built models, pre-trained libraries, so that simplifies a lot of things. So this is the actual voice, what has been spoken. Okay, it's a sample. Okay, like I said, it has some HIPAA compliance. I cannot put everything. So this is the converted voice using deep speech. Then after that, the frequency. Okay, how many times cough has been spoken? Okay, so it's spoken 2 times. Fever. Okay, chest pain, headache. Okay, like this. So this is basically like, telling the frequency of word that has been occurred in how many times. Correct? So this tells me, correct, like, where the patient has a lot of issues. It appears that the patient has a chest pain. Then we are taking that into building more of a visual form. Correct? So this is basically trying to visualize this in the form of like, how many times cough came, what percentage of the conversation that talked about this one. Okay, chest pain, how many times, like this, providing enough tools for the doctor to analyze. Correct? And this is basically giving the actual context where it has been spoken, what time it has been spoken. Correct? So if you could see, like, during the conversation and what time and what minute it has been spoken, like this, we capture everything. Okay, and then the frequency. So this is the last piece of code that what you looked at. This is basically this one. Correct? Text classification and the visualization of the data. So the visualization part, what I'm talking about, it talks about the frequency, the actual word that has been spoken, what time and what second it's been spoken, and then how many times it's been spoken. Okay, so we capture everything. So at a high level, this is basically the model that has been built for, as I told you. So converting a patient voice to a text, and from the text, analyzing text and extracting, like, symptoms, warnings, and then presenting back in the form of visualization. Okay, as I said, it's a full-scale solution. If anybody wanted to understand or anybody want to work on this one, certainly we can share with you. You can work on it. Okay, it is a very compelling use case. Similarly, we have a lot of other use cases as well. If somebody want to work on, let's say I want to do data labeling. Okay, so when I say data labeling, so you have data, like, so a customer talks about a particular product in Twitter, YouTube, Facebook, everywhere. So how do you get those data and then do a data labeling? Okay, so do a data labeling actually. So I'm just telling you, there's so many different things we can do. You can see this is basically data labeling, working with complex data sets, and how do you build this one? Okay, so this is also like, so you can see here what we have. So we can stream data from, like, Twitter, YouTube, wherever it is, then label them. And this is also done for specific purpose. So you can understand, like, this is done for giving a unified customer interface. Okay, when I say unified customer interface, means a customer goes to Facebook, Twitter, LinkedIn, correct? How do you connect all these three together and create, like, one single kind of a um, analytical platform? Whatever they spoke, whatever they do this one. So like this, there are a lot of use cases. If anybody interested, I'm happy to share with you. You can take a look at it. You'll get to know. All right. So before I do anything, I just wanted to cover some fundamentals. Okay. So whatever I spoke right now, okay, there is a lot more involved behind the scene. I want you to understand. As I told you at the beginning, okay, in my view, okay, since I've spoken to many campuses, many colleges, as I said, it doesn't matter who you spoke in India. Okay, I can confident people are not clear what is artificial intelligence, what is machine learning, what is data science, what's an intelligent automation, what is digital transformation. I am 200% confident. Correct? Everybody will have different definition. Okay, everybody will have different definition. Let's understand. Let's resolve this mystery. Okay, so this is, in my view, it's really important. Okay, in my view, really important. The rest everything, it's purely based on the use case what you are trying to implement. Correct? So like what I have given you, one use case is voice to text and text to insights, which is basically the model that has been implemented for purely on parsing the text using, like, natural language processing. So here I'm talking about behind the scene what is involved. Correct? So these are the things involved. So let's understand this really well. Okay, so I'm going to skip this one. When we typically talk about intelligence, what am I referring? Karan? I'm sure most of you know when we say intelligent, what exactly that means. Whatever you do, those are all intelligent, such as when you read something, that's an intelligence. When you write something, that's an intelligence. When you make a decision, that's an intelligence. When you solve a problem, that's an intelligence. When you respond to somebody's question, that's an intelligence. When you drive a car, that's an intelligence. Any action you take, that's an intelligence. Any task you perform, that's an intelligence. Like this, you can add to this list as many tasks, as many intelligence that you can think of, right? So these are all intelligence. Why does it calls an intelligence? Correct. If someone asks me to read a magazine, correct, which is written in French, can I read? No, I don't know. Why? I never got trained in French, so I don't know how to read a French magazine. So you see, if someone asks me to read an English newspaper, I can read. Why? I got trained in English. So that means there is certain skills and knowledge you need in order to do those things. Correct? To read something, I need a skills and knowledge and expertise. Write something, I need a skills and knowledge and expertise something. So that is what makes this as an intelligence. It is not something that you can go and do randomly. You have to have some kind of knowledge, skill, expertise. Things that what we do based on our skills and knowledge, expertise, those are all called intelligence. Such intelligence, if it's performed by a human, that is a human intelligence. That is a human intelligence. Okay, so when I say human intelligence, what exactly this means? When a human get trained, when a human get educated, the human gains knowledge. That knowledge basically used to solve these kind of problems. Okay, used to solve these kind of problems. So that is why it's called human intelligence. All right. So there is another component, which is basically an emotional intelligence. What is emotional intelligence? What we learn from human intelligence. In a human intelligence, you can take a training, either a formal training or an informal training, can use the training to solve a problem. Okay. So taking a formal training, you become knowledgeable and expert, then you can solve a problem, or you can read something, you can do something. Emotional intelligence does not need any training. Okay, you can do things without a training, without a formal training. So those are all emotional intelligence. Okay, when you do things without any formal, informal training, and emotional intelligence. For example, when you watch a comedy movie, you laugh by yourself. That you don't need a training for that. Correct? When you're looking at somebody's crying, so you try to go and console them. You tell them not to cry. So for that, you don't have to take a training. Those are all emotional intelligence. So what I'm trying to say, we understand what's an intelligent things that what we do on a day-to-day basis, reading, writing, cooking, this, that, those are all intelligence. And if that is performed by a human, then it's a human intelligence. How does a human gain such intelligence? Either through formal or an informal training, correct? Or an education. That makes human as an intelligence. If a intelligence that makes a human to do something, but that is not came through a formal, informal training, but it came through a maturity over a period of time, that's an emotional intelligence, correct? So without any formal training, when you see something, either you laugh or you cry or do something, and those are all intelligence that happens out of emotional intelligence. So we understood all the things, right? What's an intelligence, human, emotional. Now, how does this is basically connect to artificial intelligence? Okay, when people say artificial intelligence, correct, what exactly they're saying? It is an alternate or a substitute or a replacement, correct? Understand the word, correct, what I'm talking about. So this is either an alternate, okay? Either an alternate. I'm not saying that it's going to take out anything what we do. It could be in a substitute, okay? It could be in a substitute. Okay, it could be a substitute. The final only is the replacement. The final only is the replacement. When people say artificially created intelligence, okay, when people say artificially created intelligence, what is that they're trying to say? They're trying to say an intelligence which is used an alternate or a substitute or a replacement for human intelligence. And that is what they're referring. Okay, that is what they're referring. So you have to understand, correct? So we understand what's an intelligence, we understand what's an human intelligence, we understand what's an emotional intelligence. So with that, if you look at what is artificial intelligence, it's an alternate or a substitute or a replacement for human emotional intelligence, correct? Again, I'm telling you, there's thousands of people, correct, have different definition. Please ignore this is what it is, okay? Please ignore this is what it is. All right. So I understand as a concept what is this, correct? I understand this as a concept. Let's get into reality. how does this works in a real world? Okay, how does artificial intelligence works in a real world? Again, I'm telling you, there's 100 different ways people are representing without knowing this one. Okay, they put title, data scientist, this, that, and all. No, absolutely don't listen to them. So it applied in industry only in two forms, either in the form of an intelligent automation or a data science. Rest everything, please ignore, have no meaning for that. Okay. So first understand what is artificial intelligence, an alternate, substitute, replacement for human intelligence. We understand what's on a human intelligence. Now, how does this apply in industry? In industry, it is applied only in two form. Please ignore if somebody talks about nonsense. Correct? In industry, you apply artificial intelligence in the form of an intelligent automation or a data science. All right. What is an intelligent automation? An automation that occurs without a human or without any manual work. Okay. There's no human involved. There's no manual work. And this is industrial revolution. And this is where industry 4.0 comes into picture. Correct? You build industrial equipment. Such automation, I can bet nobody done this one. Okay. We are still trying to learn and do it. Okay. The best example to understand an intelligent automation, the self-driving autonomous car. An autonomous car, it's an industrial equipment or an industrial machinery. That industrial machinery works without a driver. Typically in a car, you see a driver. In a self-driving car, you don't see a driver. The car functions itself. In a traditional car, we see a driver acting when the driver sees a red light, green light, yellow light. In an intelligent automation, in a self-driving autonomous car, through intelligent automation, the car itself understands using something like computer vision, what kind of object I'm seeing in front of me. It's a red light. The instruction is given, stop. If it is a green light, the instruction go. If it is red, okay, so that is an industrial level automation. Okay, using artificial intelligence, you can build an industrial level automation such as an intelligent automation. As I said, such automation, no company done. Please keep your. So that is an intelligent automation. Second is data science. Okay, I'm not automating, but I want to extract hidden insights. For example, if you look at what we have done, the conversation that took place, a patient and a doctor, correct? They're speaking. We converted the voice to text. Now we are analyzing text using natural language processing. Then what we are doing, we are classifying the text into symptoms, warnings, etc. So what do you call that one? That is a data science. You are trying to extract hidden insights. There, I'm not building automation. All I'm trying to do, I'm trying to identify whether the patient has stomach pain, whether the patient has headache, whether the patient has fever, whether the patient has body pain. I'm trying to look for hidden insights. That is the data science. That is a data science, correct? So I want you to understand, using artificial intelligence, what can we do in real world application? What can we do in industry? Only two things. Please ignore others. Absolutely has no meaning when people talk about this one. I actually get irritated when people talk about all these things without realizing all these things. Right? So these are the only things we do. All right. Now let's connect the dots. Okay. Now let's connect the dots. So how does this comes in a big picture? Okay. How does this comes in a big picture? So you see on the top, artificial intelligence. Using artificial intelligence, we can build an intelligent automation. We can build data science. When I combine these two, it forms a digital transformation. How do I make all these things happen? And this is where machine learning comes into picture. This is where machine learning comes into picture. Again, I'm going to say, do not get confused with machine learning. Machine learning, the word, all it tells you a concept. Okay, all it tells you a concept. There is no connection between the word machine learning, the word deep learning. There is no connection. Correct? Please don't take it. It's an extension. Everywhere you read, whether it's a read in a Google search or YouTube, everywhere you see people simply say deep learning is an extension to machine learning. Absolutely wrong. Absolutely wrong. Machine learning is just a concept. Okay. Using machine learning, what can we do? That is what we need to understand. Okay. So here, what I'm trying to say, artificial intelligence, basically like, the core foundation. Using artificial intelligence, we can build an industrial automation such as intelligent automation, building an industrial equipment, building a machinery with like human, okay, like a human, it performs like a human. So that is what an intelligent automation. Second, I'm not building automation, but I'm going to look for hidden insights and extract them. That's the data science. When I combine an intelligent automation with the data science, you form a digital transformation. When people say digital transformation, they are saying information goes from A to B. Transactional information occurs without a human, without any manual intervention. Okay? Any transactional information goes from point A to B without any human or a manual intervention. That's a digital. The best way to understand digital transformation, you can look at Uber taxi business, correct? How you book a taxi, how you pay for them, how the entire transaction works. It's all fully digital. Okay, when you are traveling in an Uber car, if the car sees a traffic or it finds there is an accident, it routes them. When it routes them, it automatically does the forecast. You will be reaching the destination in next 45 minutes or next 60 minutes. What is that? That's a data science. Okay, it does the forecast. Okay, it does the forecast. That's a data science. So all the things what we are talking about, an intelligent automation, data science, digital transformation, in order to implement that, what we need, we have to teach the machine. How do we teach the machine? That is what machine learning tells you. By the name machine learning, it means nothing. It's just a concept. It's just a concept. So now the question is, how do we train the machine? There are two approaches: statistical based training methodology or neuron based training methodology. If you are going to train the machine, use neurons, then that's called deep learning. Okay, then that's called deep learning. If we are not going to use neuron-based approach, if you are going to use statistical approach such as decision tree, random forest, logistic regression, linear regression, so those are all statistical-based training methodology. How do we train the machine? Okay, how do we train the machine? There are two approaches. Point A, use statistical-based methodology. Okay, second, neuron-based methodology. If you train the machine using statistical-based, okay, so that is a different approach. If you are training the machine using neuron-based, that is basically deep learning methodology. Okay, deep learning methodology. So this is what you need to understand. When people simply say machine learning, it means nothing. It means nothing. It's just a concept. So what do you have to understand? How do we train the machine? I'm going to train the machine using statistical-based methodology, okay, or statistical tools to train the machine. In that case, you are talking about supervised, unsupervised, reinforcement, okay, those kind of models, correct? So when you're talking about neuron-based, that's when deep learning comes into picture. In both the cases, you are trying to teach the machine, you are trying to train the machine. When you train the machine, what you call, that's called machine learning. That is called machine learning. So make sure you understand. So there is heavy connection between all these words. People misrepresent. So that is why I'm trying to educate you. When we say artificial intelligence, it's just a concept. How do you apply artificial intelligence in industry? Only in two forms: an intelligent automation, a data science. When you combine these two, it forms a digital transformation. How do we build an intelligent automation or a digital transformation or a data science? So there you are coming to a conclusion that you have to train the machine. How do we train the machine? There are two approaches. One is a statistical based training methodology. Second, a neuron-based training methodology. If you are going for a neuron-based training methodology, that is called deep learning. If you are going for statistical-based training methodology, that's when you have supervised, unsupervised, reinforcement, semi-supervised, all these things falls under statistical-based training methodology. Okay? That is what it is. So simply saying machine learning, it means nothing. There is no connection between machine learning and deep learning. Okay? Machine learning, the word itself, it does not represent anything. Okay? Please do not get confused. So if you go and ask everybody in India or any other places, people will have different opinion. Someone says machine learning, deep learning is an extension of machine learning is this, machine learning is that, nothing. The word machine learning, the word artificial intelligence both represent concept, it does not mean nothing. But when you talk about deep learning, the architecture is different. It's a neuron-based architecture. There's an input layer, there's an output layer, there's hidden layer, there's sigmoid function, there's a bias, there's a weight. Those are all core architectural component. When you go for simple supervised machine learning, where you use statistical based training methodology, there we are talking about features, labels, etc. Correct? So there are different architectural components comes into picture. So that is what I wanted to understand. Correct? All right. So here I just wanted to cover one simple point. Then I'm going to stop here. Correct? So all these things I talked about. This what is machine learning? I'm just going to skip this one. There's one particular slide I'm trying to look for. Then probably I may not have this here. I will just talk about this one, right? All right. So what we are trying to do, we are trying to create intelligence artificially. How do we create the intelligence artificially, teach the machine? How do we teach the machine? Okay, you have to apply different machine learning technique. Okay, you have to apply different machine learning technique. So what we understood, there are statistical based training methodology. That's what this is. This is a neuron based training methodology. The architectural component slightly varies based on what you're trying to train the machine. Okay, what you're trying to train the machine. So there is the computer vision, natural language processing, robotic process automation. Let's understand these three, then I'll stop there. Okay, so what is computer vision? What is natural language processing? What is robotic process automation? As I explained, okay, if anybody wants you, anybody asks you, or if you wanted to know more, so the word deep learning basically tells you the machine is being trained using neuron-based training methodology. Under neuron-based training methodology, the architecture of how the machine is getting trained is different. What architecture you use, that is where you study input layer, output layer, hidden layer, bias, sigmoid function. All these things are part of the deep learning architecture. Now, I'm not using that deep learning architecture. I'm using simple statistical training methodology. So there you are training the methodology machine based on supervised, unsupervised reinforcement, semi-supervised methodology. So there you don't have to worry about input layer, output layer, etc. So here I'm talking about features, labels, correct? There are different approach here. So that is what makes the difference between statistical based training methodology, neuron-based training methodology. So based on that, you group the models in these two buckets. Here, I'm grouping them based on what I'm going to teach the machine. Okay, I'm going to teach the machine so that the machine can learn and understand language, both spoken and written. Okay, how does the machine can learn language with both spoken and written? So that is basically whatever you and I speak, the same thing machine also has to understand. When I speak to a machine, the machine understands and it builds a conversation. Not only what I speak to the machine, whatever I'm going to write to the machine, that also machine understand. How do I implement this one? And that is falls under natural language processing. The first use case that what I told you, patient voice to text and text to insights, that's fully built on natural language processing. You have seen we are using named entity recognition, NLTK packages, current, then deep speech. These are all part of natural language processing. All right. So under natural language processing, the machine learns about language modeling, sentence classification, words classification. Okay. All these things it does actually. Okay. So language modeling, sentence classification, words classification, like this. Lot of different things the machine learns under natural language processing. Under natural language processing, the machine basically learns about language, both spoken and written. Okay, both spoken and written, and that is what it does. So that basically at a high level what it is. When you speak a sentence, I want to classify what kind of sentence it is, or a word in a sentence, what kind of word it is. And that is what we are doing. We are taking a sentence, we are taking the word and see if the word is a symptom for a disease condition. Is the word is that is basically a classification that I'm doing. I'm trying to classify each and every word that is spoken by the patient, whether that word is a symptom of a disease condition or a warning for a disease condition, etc. I'm trying to classify. So that is what I call words classification, sentence classification, language modeling, correct? So you teach the machine to frame a sentence, you teach the machine to write a sentence. Other work that what we are doing, you give a resume. Okay, so one of the work that what we are currently doing, you give me a resume. In a given resume, we will rank what are the top 10 skills. That is basically fully done using natural language processing, recurrent neural net. Okay, recurrent neural net, RNN. So we use deep learning that falls under neuron-based training methodology. Under neuron-based training methodology, we use RNN, recurrent neural net, to implement ranking the resume or skills extraction in a resume. So the next one is computer vision. The word vision basically tells, if someone comes in front of me, I recognize and understand, I know that's Dr. Obilash. Okay, I know that. How do I know that's my vision? So vision stands basically, whatever you see in front of you, you have to recognize them. So this is where object recognition, gender detection, facial recognition, human recognition, all these things comes into picture. Like we as a human, how do we see and how do you understand an object? Similarly, the machine also have to understand an object. How does the machine understand the objects? That is basically computer vision. Okay, under computer vision, the machine understands audios, machine understands videos, the machine understands any pictures, images, correct? So they reads and understand images. It reads and understand like in a video, correct? So why do we have to do this one under computer vision? So computer vision basically enables you to do facial recognition, human recognition, object detection, gender detection, digit detection. So those things are falls under computer vision. How do we implement that? That's also we can use deep learning models. That is also we can use deep learning model. So understand please, under computer vision, the machine, you teach the machine to learn about an image, learn about an object, learn about a video. So once it's understand, then it does object detection, gender detection, digit detection, classification, all these things it does. Okay, all right. So we looked at computer vision, we looked at natural language processing, and we are talking about a robotic process automation. There are so many confusion around robotic process automation. You have to understand, when people say simply robotic process automation, that is not artificial intelligence. Like you may have heard about companies, Automation Anywhere, Blue Prism, okay, UiPath. So these companies they call themselves robotic RPA companies. But the word RPA doesn't mean it's artificial intelligence. Okay, it could be instruction driven. Most of the company, 99.9%, what I know, these companies are instruction driven. So programmatically, they do things, correct, without involving any human, correct? Without involving any human, they programmatically control. But when it comes to artificial intelligence, that is basically a self-learning model. It learns by itself, correct? It learns by itself, and then it performs by itself without any human and manual intervention. So you have to be a bit careful when people say robotic process automation, they are referring an instructional driven approach. So when we talk robotic process automation under artificial intelligence, that's we are talking about a self-learning model. We are talking about a self-learning model. So what robotic process automation does? So under robotic process automation, you teach the machine a business process. What kind of business process? Some of the example: order to cash, procure to pay, record to report, correct? How you do procurement? How do you place order? How do you process invoices, correct? Like how do we cook rice, correct? There are certain procedures we do. So similarly, I want to teach the machine where the machine can understand a set of process or a sequence of process. Okay, how can I teach the machine? That is basically falls under robotic process automation. Under robotic process automation, the machine learns about business processes, and then it performs whatever it's supposed to perform based on the business process, correct? So that is what the machine learns. And this can also be implemented using deep learning models, correct? Neuron-based training methodology. Okay, keep in mind, let me summarize. The number one, number two, what it tells you, how do you train the machine? Okay, how you train the machine? Number one, it's basically a statistical based training methodology. Number two, a neuron based training methodology. All right. Now, what are the different things I can teach the machine? I can teach the machine about a video, about an image, about an object. How do you do that? Why are you doing this one? And this is done for gender classification, gender detection, word classification, etc. So for that, I need this one. It's like you are a human, okay? When you see something inside, you are going to react. Similarly, when a machine sees something in front of it, it won't react. When I set the self-driving autonomous car, when it sees a green light, it goes. When it sees red light, it stops. When it sees an animal, a human, it stops. How does that possible? And that is basically you train the machine under computer vision. Okay, so this is an approach for a machine to learn about an image, object, etc. All right. So second, I want to train the machine on a language, both spoken and written. And this is natural language processing. And out of all, this is very heavily used. Okay. Natural language processing is very heavily used. So that could be an area where you can do a lot of research, a lot of work on this one actually. So that is absolutely one of the most compiling things people are doing, a lot of use cases around this one. You can explore this one. The last one is process. Okay, if you want to teach the machine where the machine can understand the business process. All right. So if you want to, if your goal, whether you are a teacher or a student or a researcher, whatever role you are, correct? I don't know. If your goal to be a subject matter expert, even to teach something, we have to be a subject matter expert, correct? Having an academic credential may not help to teach these kind of complex courses, correct? So if you want to be a subject matter expert, I would strongly encourage go deep in each one of this area and do hands-on work. That makes you very successful, very strong, very commanding authority in the subject. Okay, so rest everything, as I said, it's all noise. Ignore. Okay, so these things basically what makes you highly valuable when you do hands-on. Correct? As I said, all we are thinking. Correct? All we are thinking. If I know Python, I'm done. I'm good. But is Python alone enough? Absolutely no. Correct? So there are quite complex technologies involved. If you don't know all this technology, it would be practically impossible to connect all the dots. It would be practically impossible to connect all the dots. So that is one of the reasons that I told here. So how we are utilizing these technologies to build solutions like what we just discussed. Okay? So this is very complex. If you see what are the things used for this particular one simple use case, the entire cloud infrastructure, Kubeflow, Spark, PySpark, okay? And then Python, Pandas, MATLAB libs, DeepSpeed, NLP, Wave. So all these things has to work together. So here, all we are doing, take a voice, transform the voice to text. Once you have the text and extract hidden insights, correct? So that is basically what data science does. Okay, so it's a data science implementation. It is a use case for data science. Correct? What kind of data science we are building? We are building a data science around patient data. So we are trying to extract patient sickness, patient clinical condition, mental condition, health condition, which is hidden in the conversation. I'm extracting. Okay, I'm extracting. So that is what this use case does. All right, it's almost 2:40 a.m. for me. I'm going to stop here right now. I wanted to cover more. Unfortunately, I don't have time. And like I said, I was on a 6-hour flight from New York back to Sacramento. And I'm sitting and teaching this one. So I'm getting really tired. So sorry about it. Anyway, so maybe in another workshop, another one, I will have more in-depth discussion. We can go deeper into this one. So if anybody interested to implement this use case, what I've shown to you, we have anything, everything what you need. Like it's a pre-trained model. You can take and build this one, and you can understand how it works start to finish. Correct? We have data, we have model, we have trainings. Everything is built in. Like I said, I just have to send you the GitHub link where you can take it and then use it. So coming back to things that what I'm trying to say to you, all the things whatever I talked about, it's basically in a working system. Okay, it is not just in a concept anymore. It is in a working system. It's a heavy NLP implementation. So if you are interested, if you want to be an expert in NLP, please reach out to me. We'll go from there. Once again, I thank you for the opportunity. I hope you found this to be very useful. I know we didn't cover a lot, but at least whatever I thought, it would be like something very useful to you. Okay, please do not get confused with artificial intelligence, machine learning, deep learning, data science, and all these things. Okay, so just to summarize, artificial intelligence, it's a concept. Machine learning, it's a concept. When people say simply machine learning, it means nothing. Okay, so there is only two things what you need to understand. When people say machine learning, it's nothing but how do you teach a machine, how do you train a machine. There are two approaches: a statistical based training methodology, neuron based training methodology. The neuron-based training methodologies basically have a different architecture, such as input layer, output layer, hidden layer, bias, weight, all these things. And that is what deep learning does. The architecture of deep learning is completely different compared to other methodology, which is statistical methodology. When people talk about statistical methodology, what are they talking about? Simple supervised, unsupervised reinforcement learning, such as k-means clustering, decision tree, random forest, logistic regression, linear regression. That's what they're talking. And that is basically what when people say about like how you train a machine, teach a machine, right? So that's one. So based on what you teach, what you train, it varies. If you teach the machine an image, that's computer vision. If you teach the machine about a language, that's natural language processing. If you teach a machine about process, robotic process automation, it's must for you to understand. Okay. So the word artificial intelligence is just a concept. The word machine learning is just a concept. It doesn't have anything beyond that point. All right. Using the artificial intelligence, machine learning, what can we build? We can build intelligent automation. We can build data science. When you combine these two, we can form digital transformation. That's all you wanted to know. Once again, I sincerely thank you for the opportunity. So maybe in the next session, we have more in-depth discussion. But for now, this is the best I can do. Once again, thank you all. Take care. Bye. Ma'am, any questions? Divya, ma'am?
Yes, sir. Yes, sir.
Yeah. Any questions, sir, before I close the session?
Yeah. Request all the participants if you have any doubts. Any already sorry is in midnight in America, USA, please.
No, it's fine, sir. Actually,
Don't
so
waste the time. Yeah.
for me, it's 12:44, sir. Actually, I'm in Pacific time zone. I'm in
Thank you very
California.
much. Thank you very much, sir. Thank you very much for
No problem, sir.
providing
That's fine.
information. Yeah.
If anybody wanted to implement the use case what I talked about, like patient voice to text insights, please let me know. I can get you the GitHub access so that you can practice there. So that's connected directly to the Google Cloud. And all the tools that what I talked about, it's been implemented. Qflow, Kubernetes Doc. Once again, thank you. I wish you all good luck. Please take care. Thank you. Bye.
Thank you, sir. Thank you very much.
Thank you, sir. Bye.
Thank you, sir. Bye. Oh, the next ceremony is that valedictory ceremony. Within half an hour, we'll try to wind up. I request all the participants. If you have any queries, any doubts, any questions, please post here or send to me. Then I will forward to respective speakers. Valedictory. After this valedictory, we are going to send feedback form. Please cooperate. Yeah, I given the permission to unmute yourself.
Thank you, sir.
HODC join అవ్వమనాలా సార్?
Well, that's all for the 3-day faculty development sessions. So here it's time for validity session. So we have received an overwhelming responses from various participants from different colleges for the 3-day faculty development program on application of machine learning and data science in the emerging areas under TechUp 3 JNTU Hyderabad by eminent experts organizing by CSC, IT and AI department of VGIT. It came to an end with the now I request FDP coordinator Dr. Obalesh, professor from AI department, to brief the 3-day FDP remarks. Over to you.
Thank you, madam. Yeah, this is Dr. A. Oblesh, coordinator of this JN2H TechUp 3 FDP program. FDP program on applications of machine learning and data science in emerging areas. Now I'm going to give small remarks of this FDP. First of all, I would like to give my heartfelt thanks to our management for providing all required infrastructure and the continuous support throughout this program. Our chairman, Dr. P. Palla Rajeshwari Garu, and Srimati S. Nilma Madam, Secretary of VJIT. VJIT administration. Secondly, I would like to give my heartfelt thanks to administrative members, Dr. E. Subbareddy sir, Sai Baba Reddy sir, Director VJIT, Dr. A. Padmaja Madam, Principal, Mr. A. Mr. R. Venkatachalam, Senior Academic Officer, Mr. G. Srilata Madam, Academic Coordinator. And day one in session one, that is the 18th, I would like to thank our eminent speaker, Professor S. Samin Fatima Madam, Register Anurag University. On this session, Madam given a overview of AI, ML, and DS, data science. Each and every slide of Madam lecture is one of the research topic. Now here I'm giving one term like three light terms like while FDP, after FDP, what are the terms that are going to be in your mindset? Once again, from this FDP, through light terms, while FDP and after FDP, what are the terms that are going to be in your mindset? So from medium lecture, Turing test, one of the term, and then deep web and dark web. And day one, session two, that's the 18th, Dr. Alaya Kavati, Assistant Professor, Department of CSC, NIT, Orankal, sir given a lecture on artificial intelligence and machine learning insights. So are given a very clear picture of a complete AI and ML. From this lecture, I'm throwing one light that is a snipper.io. Snipper.io. Same day, session 3, Mr. Santosh Kumar Sahu, Programming Officer, ONGC, so are given the lecture on Introduction to Deep Learning and Data Science From SAR lecture, one of the new term, one of the true light term is Orange software, is a open source software, which is a GUI based, where we can apply any machine learning algorithm through GUI. We can design any circuit, we can design a machine learning classification, we can design a model for anything by using of Orange software. That's the term what you are going to keep with you after this FDP. Day 2, Session 1, that's the 19th Feb, Dr. Salman Abdul Moiz, Professor, University of Hyderabad, so given a lecture on exploratory data analysis. From SOR lecture, Python libraries and correlated how you can apply correlation on datasets, that too in pandas. So we learn how to load the dataset, how to apply different correlations, and then how to plot what is the significance of the plot. These are the terms what we are going to have in our mindset throughout our life. Day 2 and day session 2, that's the 19th, Mr. Madhu P, Director, Entrepreneur, Madblocks, so given a role of Python and R programming in data science. From SAR slides, we have how to connect IoT and machine learning. There's a new great term what we enjoyed from this lecture. And day 2 session 3, that's the 19th, Dr. USN Raju sir, NIT Warangal, sir given a lecture on distributed deep learning for image processing. From this lecture, so one of three light terms are image, very clearly what is the image sir given, and then a big image. We never hear this term so far. That's a big image what we learn. So third one is a cloud environment, how we can connect the systems in cloud and how to assign, how to distribute the work. And then what do you mean by distributed environment? These are the light terms what we are going to maintain in our mindset throughout our life. And day 2, session 4, that's the 19th, Sunit Kumar Gupta, PhD Computer Science, Indian Institute of Technology, Dhanbad, NVIDIA DLI Ambassador for Computer Vision. Sir is from Bennett University. Of course, Sir given a wonderful session on, hands-on session on machine learning through by using of Colab. By using of Colab, how to design a model, how to design neural network, everything Sir given. Okay. Next, day 3, session 1, that's the 28th, Mr. Kalyan K, founder and CEO, EduTech Innovations, EduTech Vision. Kalyan sir given data science and use cases. In this session, we enjoyed what are the IoT use cases through videos. Thank you, sir. Thank you very much. And day 3, session 2, head of the day 3, session 2, uh, Radhakrishna sir, head of the department of NIT Warangal. That's Sir given the lecture on applications of machine learning and data science. From Sir lecture, two terms: modality and factual captions. Now, factual caption is one of the research direction. Those who are interested, go ahead. Thank you, sir. Thank you very much for giving a new direction for research. Day 3, that's the session 3. That's the 20th February. Mr. Jyoti Periswamy, Learning Facilitator, Artificial Intelligence for Business, and MIT Sloan, Boston, USA. Even it is midnight in USA, Sir spared some time for us for giving a very clear picture of what is exactly definition of artificial intelligence and machine learning and deep learning. Of course, everyone can give a definition for all these terms, but what exactly conceptual difference between these three terms very clearly Sir explained for us. Thank you, sir. Thank you very much. That's a theolite is. That's what a difference between all these three terms. For all these sessions, I'm very happy to share you. For every session, 100 plus active participants are there, and through YouTube and Zoom link. Thank you very much. Thank you very much for all the participants. Last but not least, I extend my sincere thanks to TechCube 3 FFDP organizing committee, without whom this program has not possible. It has been our pleasure to host this to all the participants. The participants were very enthusiastic, and I am thankful to them for their participation and bearing with us throughout this program. Our college organizing committee, FDP organizing committee, Dr. B. Vijay Kumar sir, head of the CSC department. Mr. B. Srinivasan sir, head of the IT department. Dr. Siddhartha Ghosh, head of the AI. Sorry. This is hopefully myself, Vijay Shanti Madam, Associate Professor, Department of IT, and Ms. Divya S. Divya Ma'am, Associate Professor, Department of CSC. Thank you all once again. Thank you all the participants for giving such a nice cooperation for conducting this FDP in smooth manner. Thank you once again. For all the participants, still if you have any clarifications or any doubts, we can support, and whatever the slides we can collect from the speakers, we can forward to you all. And within 2 to 3 days, you are going to get your participation certificate. Depends on your feedback forms. Thank you once again. Thank you all. Thank you for Vijay IT. Thank you for all the participants. Now I'm putting a full stop for my remarks on FDP. Thank you very much. Now over to Divya ma'am.
Thank you very much, sir, for the brief of the 3-day faculty development program. I now request Dr. B. Vijay Kumar, sir, head of the CSC department, to speak few grand success of 3-day online FTP program. Over to you, sir.
Madam, am I audible to you?
Yes, sir.
Good afternoon to all. First of all, I would like to thank all the participants for attending all the sessions of this 3-day FDP on applications of AI and machine learning and data science. And I have seen the feedback also. So everybody is given very good feedback about the sessions that they have attended, and they have shared their views also about the sessions, and they are very informative, and the speakers have given different directions towards research also. Few sessions with practical case studies, and also we actually planned for hands-on sessions, but due to lack of time, we are unable to extend the FDP for 1 week. It is only organized for 3 days. Next time, definitely, by considering all your feedback, we will definitely organize for 1 week or 2 weeks FDP on emerging technologies. Okay, I thank all the participants once again for attending this FDP and making it successful. And I also congratulate and thank all the organizers of this FDP for conducting very smoothly and organized manner. Thank you all for giving this opportunity.
Thank you very much.
Thank you, sir. I now request Dr. B. Srinivasan, sir, head of the IT department, to address the participants on success of 3-day online FTP. Over to you, sir.
Good afternoon all. Thank you, Devi madam. On behalf of Department of IT and behalf of VJIT, let us thank JNTU TechUp 3 team who has approved 3-day FDP and sponsored. Maybe let us thank and Director Sir Sai Baba Reddy sir, Principal Dr. Padmaja madam, who is responsible and make sure that we got funding from JNTU, and as well Vijay Kumar sir, CS HOD, Siddharth sir, AI HOD, and Oblesh sir, Vishanti madam, Divya madam, and all other people, those who are directly or indirectly involved in making this FDP a success, a grand success, I can say it as told by Oblesh sir. There are almost 12 speakers or 12 people, those who involved and shared their research ideas, and given, and I'm sure that the people, those who participated in the workshop, has got really benefited by attending different sessions, as told by Oblesh sir. Right. Once again, let us hope that, as told by Vijay Kumar sir again, due to either lack of time or due to COVID reasons, we could not have the FDP in campus. So otherwise, we initially planned to have the same FDP in campus, but because of various reasons, we could not have. Okay, so let us hope that in future, continuation of the same workshop or FDP, hands-on sessions and all, let us plan for the next time. So thank you all. Thanks for giving me the opportunity. Thank you.
Thank you very much, sir. Thank you very much.
Thank you, sir. I now request Mrs. Shanti Madam to conclude the session with a word of thanks.
It's my pleasure to propose vote of thanks for 3-day faculty development program on applications of machine learning and data science in the emerging areas organized by the departments of CSC, IT and AI at Vidyajyoti Institute of Technology under TechIP 3 JNTU, Hyderabad. I would like to thank my management, Dr. Palla Rajeshwar Reddy sir, Chairman, Anurag Group of Institutions, Mrs. S. Seelima ma'am, Secretary and Correspondent, Anurag Group of Institutions, for their constant support to conduct this event. My heartfelt thanks to Sri Jayesh Ranjan, IAS, In charge Vice Chancellor, JNTUH, Professor A. Govardhan sir, Rector, JNTUH, Mr. Manzoor Hussain, Registrar, JNTUH, Dr. P. Padmaja Rani, Professor, CSC Department, and TechIP Coordinator, JNTUH, for accepting our request and sponsoring this FDP to organize this event at Vidyajyoti Institute of Technology under TechIP. Thank you, sir, and thank you, ma'am. Now, I extend my sincere thanks to our Director, sir, Dr. E. Sai Baba Reddy, sir, our Principal, ma'am, Dr. A. Padmaja, ma'am, Academic Coordinator, Srilata, ma'am, Senior Administrative Officer, Venkatachalam, sir, for their continued support and encouragement to organize this 3-day FDP program successfully. Thank you, sir. I convey my sincere thanks to all the eminent resource persons, Dr. Samin Fatima, ma'am, Registrar, Head of AI Department, Anurag University, Dr. Ailaya, Professor, NIT Warangal, Dr. Santosh Kumar Sahu, Program Officer, ONGC, Dehradun, Dr. Salman Abdul Moiz, Professor, Central University, Mr. Madhu Parvataneni, Director and Entrepreneur, MedBlock, Hyderabad, Dr. USN Raju, Professor, NIT Warangal, Dr. Suneet Kumar Gupta, Professor, Bennett University, Noida, Mr. Kalyan K, Founder and CEO, EduTech Innovations, Hyderabad, Dr. Radhakrishna, Professor and Head of CSC Department, NIT Warangal, Dr. Jyoti Periyasamy, Learning Facilitator, Artificial Intelligence for Business, Boston from USA. Thank you, sir. Thank you all. In spite of their busy schedule, all they accepted our request and they have given their valuable time for us to conduct this 3-day FDP. I think all the sessions are wonderful sessions and goes in a practical way, which really help all the participants to enhance their skills in the field of AI, ML, and data science. And I hope all the sessions focus many research areas in the field of AI, ML, and deep learning. Thank you, sir. Thank you for all the wonderful sessions. I extend my thanks to all the FDP coordinators, Dr. B. Vijay Kumar, sir, Head of CSC Department, Professor B. Srinivasulu, sir, Head of IT Department, Dr. Siddharth Ghosh, sir, Head of IT Department, for their support to organize this event successfully. I also thank department coordinators, Dr. Woblesh, sir, Head of, Professor AI Department, Divya ma'am, Assistant Professor, CSC Department, and myself, Vijay Shanti, Associate Professor, Department of IT, for their tremendous efforts for the smooth conduction of this 3-day FDP. Thank you, sir. Thank you, ma'am. Last but not the least, I thank all my dear faculty and friends and the participants from various engineering colleges to make this event a great grand success. Thank you. Thank you all once again. Thank you all.
Thank you, madam. Finally, I request all the participants to please fill the feedback form, which is provided available in the chat box, and make sure that you enter your name and organization in an accurate manner. Thank you.
So there are some queries, sir.
Before we conclude the session, we'd like to have feedback from the participants.
Now I request participants share your experience share your experience, share your feedback. It's a very useful for us to conduct further events. Now I request one of participant. Bindu madam. I am requesting one of the participant.
Good afternoon, everyone. I am Ashwini Gaur from PhD College of Engineering and Technology.
Complete, sir.
Hello, could you hear me?
Madam, who is ma'am?
I am Ashwini Gaur from KG Reddy College of Engineering.
Madam,
and
if it is
Technology.
possible, make your video on.
Complete, sir. ఇంకా పంపలేదు. నేను పంపిస్తాను.
Good afternoon, everyone. I am Ashwini Gaur from KG Reddy College of Engineering and Technology. All the sessions are very pleasant, sir, and such type of sessions can be also conducted offline for more, so that we can easily understand and we can clear the doubts there itself, and we feel free to clarify doubts personally. And as of now, it is a very good session, and we got much knowledge about what are the things which we don't know yet, and we are now capable of performing some experiments also by reviewing all the things shared by the eminent personalities, all the resource persons. And hope in future such type of activities we are interested to attend offline too.
Madam, thank you, madam. Thank you very much.
Thank you, sir.
Now I request one more participant. Now I am going to share a feedback form. Meanwhile, please, one of the participant, please share your experience. Yeah, just now I given a link for last session feedback form. So please, all of you fill the feedback. Now I'm expecting at least one more participant. Ramadevi madam. Madam, MGIT from MGIT, Himabindu, madam. Vijay Kumar, sir, thank you very much. Nallamallareddy Engineering College. Aruna Shanti, madam. Ashwini Gaud. Ashwini Gaud Pillala. Thank you, madam. Thank you very much. You are most active participant. Madhavilata, ma'am.
Thank you, sir. Thank you so much for conducting such a workshop. Thank you. Thank you.
Madam, 1 minute. Make your video on, madam.
Thank you, sir.
For JNTU purpose, just I am requesting. Recording purpose. Thank you, madam. Thank you very much.
Thank you very much.
Madhavilata, madam. Bennett Titti. Every time, every session, I seen your name, Bennett. By exact time you are joining. Chirugu Radhika, ma'am. Chinta Veena, ma'am. Vijay, sir. Najee Sheikh. Ramadevi, madam. CMRIT. You ask so many doubts for the speakers. Thank you, madam. Thank you very much. Ramadevi, madam, are you there? Please unmute yourself and yeah. Okay, madam. Monica, ma'am. Farhin Sultana. Harshavardhan. Jyoti Ravi. Usharani. Kavita, ma'am. KSK Sharma, sir. Parimala, madam. Manasa, madam. Nagaraj K. Nagaraj K. Katta Nagaraj from Godavari, Rajahmundry. Thank you, sir. Thank you very much. Narendran. Sai Kumar Tara. Tara, sir. Thank you very much. Soumya, madam.
Thank you,
Please.
sir. Thank you. Thank you.
Hello. Bennett program is very successful. Thank you, sir. If you don't mind, please make your video on, all of you. All of you, please. All of you make a video on. Just we'll take one screenshot. All the participants, please. Swapna, madam. Thank you very much for joining us. Tara, sir. Thank you. Thank you very much.
Nice
Soumya, ma'am.
organization of session, sir.
Thank you. Thank you, madam. Manasa, madam, can you speak anything? Narendran, sir. I request all the participants, 1 second, please make your video on for feedback purpose. One second, all of you, please. Ujwala, madam. Hi, Bennett, sir. Can you speak something? Can you give any suggestions? Bennett, sir.
No suggestions right now. The session was very, very good, sir.
Thank you very much, sir. For every session you are joining on time. Thank you very much. Thank you for your interest. N. Srinivas, sir. Thank you very much. Now, once again, I am requesting all the participants, please make your video on. Very few people are made on. If it is possible, please, all of you. Yeah, thank you. Madhavilata madam, thank you. Jyoti Ravi. Thank you, sir. Thank you very much. Madam, can you speak something? Feedback. Jujula madam. Madam, Swapna madam, any feedback? Give me a feedback.
The organization of sessions were very good, sir. Especially the sessions of Salman Moiz, sir, and Jyoti Periya Swami have helped me a lot for my research, sir. Thank you very much for organizing this session, sir. Every
Thank you.
session was very good and interesting.
Thank you, madam. Thank you very much. Yes, thank you very much, ma'am. Already given the feedback link. Once you fill all of you fill the feedback and then leave the session. Thank you very much. Thank you all of you. If you fill the feedback, then you can leave. Thank you, sir. Thank you very much, and we can meet in coming future event. Thank you all. I'm expecting same cooperation in future also from all of you. Thank you.
sir.
Thank you, Swapna ma'am. Sweta, Sweta madam, Sunita madam, Rathod, Navya ma'am. After filling the feedback, you can leave the session. Thank you all of you. Thank you once again. Thank you very much. Still 20 members are there in chat box. Participants list. Narendran sir, thank you very much, sir. Arts and Science College.
Sir, could you please share today morning second session feedback form? Have
Sorry,
missed
ma'am,
it at
I'm
the
not
end.
here. I'm not audible. Madam?
Hello, sir.
Yeah,
Could
tell
you
me,
hear
ma'am.
me? Could you please share the session 2 feedback form? I have missed it at the end of the session.
Yeah. Okay, ma'am, I will forward.
Thank you,
Shall I
sir.
forward in chat box or in person? Yeah, WhatsApp.
Anywhere, sir, anywhere. Radhakrishna sir feedback. Eighteenth Jan.
Yeah, day 3 session 2 feedback I given in chat box. Once you check it.
Thank you, sir. Thank you very much.
Thank you, sir. Narendra sir, excellent session. Hats off to organization team. Thank you, sir. Thank you very much.
Sir, it is showing that you have already responded to the sheet.
Yeah, that's if you already responded. Wait.
No, I did not. Okay. I have missed it actually.
Okay, madam. Thank you. Sai Kumar sir, any final links? No, sir. We are going to forward all the slides and the certificates. Within 2-3 days, we are going to get your participation certificate. Depends on your feedback form, attendance form, and all.
Sir, are you going to share all the PPTs to our mail IDs individually?
Sorry, ma'am.
Are you going to share to our mail IDs individually the PPTs?
I will create. I will create one. I will kept all slides in the Google folder, madam. I will give a link for all.
Okay, sir. Thank you.
Yeah. Thank you.
Can we leave now?
Yes, ma'am. Thank you. Thank you very much, ma'am. Thank you very much. After filling the feedback, please have a good time. Okay, you can leave the session. Anuradha madam, thank you madam. Nagaraj sir, thank you. Sai Kumar Tara, Srija, Lakshmi Prasanna, Madhuri Timmapuru, Rathod Sweta, Madhreddy. Thank you all. Thank you once again. With your permission, just I'm closing the meeting. Any queries, any doubts, please call me.